Today we are going to learn about congruence and how to determine if two figures are congruent, and how to show congruence also. So first of all, hopefully we know that the word congruent means the same size. So two figures with the same side lengths and the same angle measures are congruent. So if you have two figures and their sides are the same lengths and their angles have the same measures, then those two shapes are congruent. And the symbol that we use for congruent has kind of this squiggly line over top of your equal sign. So that's your symbol for two things being congruent. Two figures can be congruent if the second can be obtained from the first through a series of rotations, reflections, and or translations. So you will notice that dilations are not a part of this list. If something is dilated, it either got bigger or smaller, and so then it is not congruent to the original shape. If something is rotated, reflected, translated, or even a combination of multiple of those transformations, those three, then the image is going to be congruent to the pre-image. And so you might hear those three transformations, rotations, reflections, and translations. You might also hear those called rigid motions. And so a rigid motion just means either a rotation, reflection, or a translation. All right, so the first thing we're going to do here in this first example is determine if the two figures shown are congruent by using transformations. And we're going to explain our reasoning. So really, if these two are congruent, we can prove it by making a transformation or a reflection, rotation, or translation. So if we look at these figures, if we start with triangle ABC, and we're trying to match it up with triangle XYZ to prove that they are congruent. The first transformation that I would make is I would probably rotate triangle ABC over the, reflect triangle ABC over the y-axis, right? And when we do that, you would see that that point B would become right here, right? And so once we do that, we would rotate, and then we would also need to go ahead and move it a few units down. So we said point B would be here, point A, if I reflected, would be, let's see, 1, 2, 3 right here, and point C after that reflection would be right here. And so if you look at those points, they're really, really close to matching up, but each one is 2 units above. So in order for those to totally match up, we would have to take each point and translate it 2 units down, right? So we can go ahead and say that triangle ABC can be reflected over the y-axis, then translated 2 units down to form triangle XYZ. And so that makes them match up. Therefore, we can say triangle ABC, and I'm going to use our symbol for congruent is congruent to triangle XYZ. So really what we did there is we proved that these two figures are congruent by looking at what transformations would be required in order to make them match up. So because the first triangle can be reflected and then translated, those are both rigid motions, these two are congruent. They are the same size. there are a couple more problems down here to practice that are kind of the same thing. And so when we look here, these don't have the coordinate plane, so you're not going to be quite as exact on this. We're not going to know what axis we're rotating or reflecting over. We might not know how many units we are translating, but I think we can still kind of get the idea here of figuring out whether these are congruent or not. Here we have figure A and figure B, and I think you can see that our first step would be we would need to reflect over this dotted line that I just drew in. And so if I reflected parallelogram A over that line, I would be really, really close to matching up, and then we would need to translate over. So we could reflect and translate to make those match up. So you could say that figure A is congruent to figure B by a reflection followed by a translation. In this second problem over here, I could see some of you thinking maybe if we could rotate this, we might get close. If we could kind of flip it, that might help. But when we look really carefully at these two figures, you can see one main difference. Right here, where we have these 2 units on top, in this picture, there's one empty space between them, right? There's kind of like one block unit there. And over here, when we look at those 2 same pieces, there are now 2 empty spaces in between them. So that tells us that these 2 figures really aren't even the same. There's nothing that a reflection, a rotation, or a translation is going to do that is going to increase the amount of space between those 2 blocks that we're looking at. So for that reason, these are not congruent because you cannot reflect, rotate, or translate in order to get from that first figure to the second. All right, the next thing we're going to talk about is corresponding parts. Parts of a congruent figure that match or correspond are called corresponding parts. And we talked about this a little bit in class yesterday. When we were dealing with dilations and scale factors, that in order to find the scale factor, we had to make sure we were comparing corresponding sides. So remember, that means like the same side in each figure. If 2 figures are congruent, then their angle measures and side lengths are all congruent. So all of their corresponding sides or parts would also be congruent. Okay, so that refers to their sides and their angles. If you have corresponding figures, then if you have congruent figures, then their corresponding sides are equal and their corresponding angles are equal. So one way to show that is with this picture here, with these 2 figures. We have figure MNOP and figure ABSK. And so you can see all of these tick marks and all of these arcs on the inside with the angle measures show your corresponding parts. So these tick marks tell us that whichever side, like here, side AS has 1 tick mark, its corresponding side in the other figure also has 1 tick mark, right? So the number of tick marks kind of shows what your corresponding parts are. So side PO is corresponding with side KS, and so on. So we can actually write what we call congruency statements. For example, if I was going to write congruency statements here, I could say that side AS, and that little line over top of my AS, that means that I'm talking about a side. So side AS is congruent to side MP, right? Those are my corresponding parts. I could also say for another pair of corresponding sides, I could say side AB is congruent to side MN, right? Those would be these sides right here with those 4 tick marks. For the angles, it's kind of the same idea, your same corresponding angles. Angle A has 1 arc, right? You can see right here, it has that 1 arc in that angle, and so it is corresponding to angle M in the other figure because that also has that 1 tick mark. Those are your corresponding sides or your corresponding angles. And another way to figure out what angles are corresponding if those marks are not in the figure for you is really just thinking, okay, if I reflected over this line here, that line of reflection, that's how I would get these 2 figures to match up. And when I did that, angle A and angle M would kind of match up with each other. Okay, another example of a corresponding set of angles would be angle K is congruent to angle O. Those would be corresponding angles as well because they would match up if you were to go ahead and make that reflection. All right. So the next thing we're going to do is we're going to actually put in our tick marks to show our own corresponding sides. It says write congruency statements comparing corresponding parts in the congruent triangles below. Use matching arcs and tick marks to show the corresponding sides. So right here, I can go ahead and I'm going to start by labeling my triangles. I have triangle A, B, C, and I have triangle D, E, F. So to start with, we are going to label, let's start with our corresponding sides. It might be easiest to say, well, the hypotenuse of each of these, that is a corresponding side, right? So side AC then is congruent to side DF. Another pair of corresponding sides is going to be BC and EF, right? Those shorter of the 2 legs. So side BC is congruent to side EF. And our last pair of corresponding sides would be side AB and side DE. So side AB is congruent to side DE. Okay. Then we're ready to go ahead and look at our angles. So for our angles, if I start here with angle A, the corresponding part to that would be angle D, right? Those are the angles that would match up if we were able to kind of turn these figures to overlap with each other. So it's a angle A is congruent to angle D. Angle B here, that's our right angle. I'm putting 2 tick marks there, or 2 arcs, is congruent to angle E. So angle B and angle E. And lastly, that leaves us angle C and angle F. So angle C is congruent to angle F. All right, so we're all finished there. Like I kind of said before, we used our arcs, that's the blue things, and our tick marks, those are these kind of fuchsia pink lines to show the corresponding sides. And when it said write congruency statements, that's what we did kind of right here, is we wrote our congruency statements. So these right here, those are your congruency statements. All right, let's go ahead and take a look here at one more problem. It tells us here that triangle ABC is congruent to triangle XYZ. We're going to write congruency statements to compare the corresponding parts and determine which transformations map triangle ABC onto triangle XYZ. So again, congruency statements, that's what we just did. So when we look here, if we start with our sides, we know that side AB is congruent to side YZ, right? Those are corresponding sides. Side BC, the longer of your two legs, is going to be corresponding with side XY. So side BC is congruent to side XY. And lastly, side AC is congruent to side XZ. For the angles, same idea here, nothing too new. We have angle A is congruent to, let's see, that would be angle Z, right? And so if these get hard to tell, another way that I looked at that was saying, well, here angle A is between the side with 1 tick mark and 3 tick marks. So the angle that it's corresponding to has to be in the same place between the side with 1 tick mark and 3 tick marks. So angle A is congruent to angle Z. Then for our next one, we can see angles B and angle Y. I'm not drawing my arcs in there, so I'm a little bit out of room here. So angle B, that right angle, is congruent to the other right angle in the other figure, which is angle Y. And our last set there, angle C, would be congruent to angle X. So we've got all of our congruency statements there for all of the sides and the angles. That's all of our corresponding parts. And the last thing it wants us to do is determine which transformations map triangle ABC onto triangle XYZ. Well, we would definitely need to reflect that, right? We would need to flip triangle ABC. So reflection. And since this is not on the coordinate plane, it's not necessarily over the y-axis, but over a vertical line, right? It needs to be reflected over a vertical up and down line. And then it would probably need to be shifted a little bit or translated down and maybe a little bit to the left after that reflection. All right. The last kind of new thing that we're going to do here is look at this problem here. It says Miley is using a brace to support a tabletop. In the figure, triangle ABC is congruent to DEF. If the measure of angle CEB is equal to 50 degrees, what is the measure of angle FGD? So they wrote those angle measures in a different way than we've seen before, right? They said angle CEB. Before we've just seen like the measure of angle C. The reason that they write it that way is so that you know what angle exactly we're talking about. Because when we say angle E, we could be talking about the angle right here, angle E, or you might think that we're talking about the outside angle there, angle E on the outside. So when they say CEB, it helps us to see exactly which one we're talking about. We're talking about the angle E that also connects to C and B, right? So CEB. You can always find that angle if you start with the first letter, take your pencil and kind of connect to those 3 points CEB. That's going to tell you what you're looking at. And it tells you that these two triangles kind of in the corners of your tabletop are congruent. And we're being asked to find the measure of FGD. So here, FGD. Well, when we look there, if those are corresponding or congruent triangles, then angle CEB is going to be congruent to angle FGD. Those are going to be corresponding parts because really this is just a reflection, and you can see how those two angles would line up. So then if the first angle CEB is 50 degrees, then the measure of angle FGD is also going to equal 50 degrees. So you can see how kind of knowing that two things are congruent can help us also to find missing angle and side measures. All right. The last thing I'm going to have you guys do is try 2 problems here on your own. So these 2 bottom problems, these are for you guys to practice. So take a read through these and see if you can do these on your own. These are really similar to what we've been doing in this whole video. The first one, you're going to write congruency statements for all of your corresponding parts. That means your sides and your angles. And you're going to put in those tick marks and arcs to show your corresponding parts. In B, the second problem, you're looking back up here at the same picture that we just used. So when it says in the figure above, it's talking about that same tabletop figure. If you guys have questions today about anything in this video, or if you need help on these last two problems, please send me a message. I will be online today until 3 to help you guys if you need it.